Now, I don't know if you guys realize, but section 10.5 is not in our curriculum, so we're not doing section 10.5. If you looked at the homework sheet, do you see how there's no homework for section 10.5? Okay. So we're going to get into 10.6, and that'll be the last thing we do today. Let me make sure I didn't... Oh! There is one last thing that we have to do in section 10.4.
Rationalizing the denominator.
So, first thing I want to remind you guys about, what kind of number is this? Like, this is an integer. This is a... I'm going to give it away if I say with that. What kind of number is that? Rational. So this is not rational. So it's irrational. I like it. Like pi is irrational, so forth. But if I was allowed to, couldn't I multiply this by something to make it not irrational anymore? What would I multiply it by to make it not irrational anymore? Square root of 11. All right. Why? Because I can't do the square root of 11 because there's only one 11. So if I can give it one more 11, I can do it. So that's the idea. I'm not allowed to just multiply something out of nowhere unless I have a fraction. Then I can multiply top and bottom. All right. So that's the idea. And what I actually call this, I don't call it rationalizing the denominator. I call it completing the root. And you'll see what I mean, maybe. So, for example, if I have 2 over the cube root of, doesn't matter, just 5. So that bottom is so irrational. Can't even talk to it. No, this is for me. Why can't I do anything with that bottom? Because how many things does it need on the inside? It needs 3, because it's a cube root. How many things are currently inside? 1. There's 1 5. So how many more 5s does it need? So do you see why I call it completing the root? The root requires 3 things. I currently only have 1 thing. So let me give it 2 more of those things. And why am I allowed to do that? Because if I multiply the bottom by cube root of 5 squared, there's the other 2 5s I don't want to give it, right? Let me stop there for a second. Is everybody cool with that so far? If I didn't do that, if I just did it times this, am I allowed to put those together?
No.
Shit, so I better do the same root, so I'm allowed to put them together. If I do that to the bottom, I better do the same damn thing to the top. That's what makes it legal. So on the top, now the top is disgusting. But it is convention in math. It's already bad to divide by something, and it's really even worse to divide by a gross thing. So we move the grossness up top. So now I get, what do I get? I get 2 cube root of 5 squared, so we'll just write 25 there. Is that cool? Now what do you get on the bottom?
5.
Yes, because you get the cube root of 5 cubed, which is 5. Let me stop. That's what they mean when they say rationalize the denominator. They mean make it not irrational. Give it what it needs to become a nice whole number. I have no idea how you feel about that. As always. So yeah, let's do another one. What if I had 4 over the 7th root of b to the 4th power?
Multiplied by 7 to the b to the 4th power.
Yeah, it's silly. 7th root needs 7 things. I currently have 4 things inside. Let me give it 3 more of those things. Let that be simple. So I want to give it 3 more b's so that matches the root. So on the top I get 4 times the 7th root of b cubed. What do I get on the bottom? B, because I get the 7th root of b7, which is b. How are we doing with that? Is that? I mean, it's almost. Let it be almost too simple to believe that's how it works. Look at the root. It needs this much. What do I have so far? Let me give it what it's missing, and then I'm done. Top and bottom. All right, so let's do. They can't always be that nice. I've given you some nice problems. Let's do some not so nice problems. Like it.
So you can put it all in the fifth grade, right?
Yeah.
7 over 8, 80.
Well, no. It doesn't really help you. If that was like a 16, it could help me because then I could reduce those, but it's a 7. And the instructions tell me rationalize the denominator. So, how many more A's does it need?
4.
And how many more B's does it need?
1.
Now, is it correct? I'm going to say this incorrectly, and somebody figure out why. I need 4 more 8's. That is incorrect. Because what is 8?
3 cubes.
I already have 3 2's, don't I? So 8 is 2 times 2 times 2. 8 is 2 cubed. So how many more 2's do I need? 2. So multiply by the 5th root. I need 2 more 2's. Told me that I need 4 more A's, right? 1 more B. The first step, I have no hesitation to say that the first step is easy. It just is. Why are there not 5 of these things? Okay, make it 5 of these things now. I mean, I guess, I don't know how to. So then what do I end up with? On the top, I end up with 7 times 4. Same root, right? Yeah, so I get 28A4B. So the top just gets, it's going to be gross. We can only make one thing look nice. So the top looks gross. Oh well. But the bottom now, some of you guys might realize the bottom is 2AB. I constructed it to become that. Because I get the 5th root of 2 to the 5th, A to the 5th, B to the 5th, and the 5th root and the 5th power is all cancel. Bam. 7 times 4. 2 squared is. So in the final answer, you don't write any numbers to powers. You go ahead and put them as numbers.
How'd you get the 2 squared? Like, how did the 8 turn into a 2?
8 is 2 times 2 times 2.
Cubed, right? But not.
2 cubed.
So then the other 2 comes because you're trying to make it 5?
Yes.
Okay.
Why am I trying to make it 5? Because that's how a 5th root wants to work. You see, I mean, that's it. Why did I give it 4 more A's? Because it's already got 1, I want to make 5 of it. So why did I give it 2 more 2's? Because it's already got 3, I want to make 5 of it. Are you wrong if you give it 4 more 8's? No. But your final answer, you're not going to be done. You can reduce it. You use too big of a number, it'll be reducible. Now that gets gross, so don't do that to yourself. Here, so you guys try this one. Oh, very nice.
Is that 7Y?
7Y, yeah. So do you need 2 more 9s? No, because 9 is
One more
3 squared, so you need 1 more 3, 2 more A's, 1 more B. So on the top you just slam them together. On the top you get 21 A squared BY. I mean, the top normally just slam them together. On the bottom, what do you get? Some of you guys realize it's 3AB. We constructed it to be 3AB because I get the cube root of 3 cubed x cubed b cubed. Right? Because I made it that way. I did it. So then the cube root and the cubes all cancel. So you have the cube root of 21a squared by over 3ab. Then I can kill those, right? I can cancel that? Good, of course I can. I can't break into a cube root. I can't divide these because 3 does not have the same root as 21. So I can't, there's another way to look at it. So don't let your brain do that. So that's, all right, so.
So what did you do there? Oh, I'm sorry. Equals 3 for the equals cube root of 21a to by.
Yep. So just multiply that times that. Because I'm going to multiply top and bottom by the same thing.
Oh yeah, okay.
7 times 3, a squared by.
Yeah, I thought you cross multiplied.
Oh, no.
I wasn't looking, they're exactly the same.
Oh, yeah, exactly. That's what makes it legal. So that is the same as this. It just looks different. This has a radical on the top and bottom. This only has a radical on the top. So it is kind of slightly better. I know you're all like, they're both bad. But that is slightly better than that. So, real quick. This is related to one that was on that group work we just did. Alright, you suck. You, I think, are the suckier one. Okay, you're the one. Okay. What do I get here? If you multiply that out, some of you notice what kind of form that's in? It's like a difference of squares, right? So the middle terms should cancel. The middle terms are the only ones where radicals would still be left alive. So this is a remarkably disgusting number. It's completely irrational. This is completely irrational. Gross number. Gross. Poor little number, but it's gross. What do you want from me? But what do you get when you multiply? What's rad 2 times rad 2? 2. And then you get plus rad 10 minus rad 10. Is everybody cool with that? The middle terms cancel. What's rad 5, rad 5? 5, so you get negative 3. That truly horrendous number times that truly horrendous number becomes negative 3. And you're all like, okay. But so, keeping with the idea that rationalizing the denominator means making the radicals go away, if I have this, how do I make the bottom not irrational anymore? Multiply it by that. And I don't know if anybody know the name of that in this case. It's called the conjugate. So this is a conjugate pair. Conjugate, I don't know why we use that word. It's like if you take a foreign language, you conjugate your verbs, but it's got nothing to do with that. Anyway, alright, so the idea is, if I only multiply by rad 2, that will become 2, but that becomes rad 10. It's still got a radical. If I multiply by rad 5, that's 5, but that's rad 10. So I got to kind of multiply by both of them somehow. And that's how I do it. So I multiply by rad 2 plus rad 5. what do I end up with on the top? I'll do the top. Yay. The bottom, we already did the bottom.
-3.
Yeah. And you can put the negative on the top or whatever, but who cares? I mean, that's been rationalized. The bottom is no longer irrational. The bottom is an integer.
So you just don't want irrational denominators?
Yes. To be completely honest, there are some times that you want to rationalize the numerator. So you do everything we just did, but you would, like up here, you give it 2 more 7s and 2 more y's and go the other way. Because there are situations where that helps. It doesn't sound like there should be, but that doesn't happen until like, what am I thinking about? Until calculus, I think. Calc 1 or 2? Yeah. So now watch. So what would you multiply this by to get it going? So rationalize the denominator. So what are you going to multiply by? It's conjugate. The conjugate, 11. So you're going to multiply by square root of 5 minus square root of 11. If I had said rationalize the numerator, you would have multiplied by square root of 7 minus square root of 3. Yeah, exactly. So you just do the conjugate of whichever one you're looking at. So on the top, you got work to do. Oh shit, what's rad 7 times rad 5? Rad 7 times negative rad 11. Rad 3, rad 5. Rad 3, negative rad 11. Over. Rad 5, rad 5? 5. Rad 11, rad 11? I like it. So then I got rad 35 minus rad 77 plus rad 15 minus rad 33. No like terms, nothing I can do with that shit. All over negative 6. Yes, sir.
Rad 5 minus rad 11. Where do you get the minus sign?
So again, that was the whole reason for this. These are like difference of squares, pairs, right? Like x plus 2, x minus 2, that kind of thing. So the middle terms cancel. Do you see how the middle terms are the only places where a radical would still be? Do you see that? The rad 2 becomes a whole number. Rad 5, whole number. This would be rad 10, but I set it up so that the middle terms cancel. So something times its difference of squares pair will always come out to be a nice integer.
So you wanted that, yeah?
Exactly. Yes, because rationalize the denominator means make the radicals go away. But I can't just multiply by rad 5, because that would become rad 55. And I can't just multiply by so I got to multiply by both of them at the same time. And this is how I do it to make it work. I multiply by the conjugate, which really just says change the sign in the middle so they look like difference of squares.
So it's not negative rad 5 minus...
No. It's like if I said I factored the difference of squares, and I said part of it was x minus 10, what's the other part? There, that's the conjugate. So that's rad 5 plus rad 11, the other one's rad 5 minus rad 11. I like it. Okay, so that was the last little bit in section 10.4. Rationalizing the denominator. Sure, I just want to do a little bit of 10.6, and then I'll let us out of here at what has become standard time, almost, I guess. Ouch. So somebody help me out. This is going to be nice. This is not what this section is about, so don't get too excited. This should be remarkably easy. But what definitely should be your first step? There's several ways to do this, but there's one best way. Hell yes. Get rid of my fraction, alright? So here's the thing with my variable in it. If I can get that by itself, so multiply by 5, then everything should be easier. Right? So then, is that cool? So then multiply by 5, x equals 3 equals 10, x equals 7, cool. So, okay, what if I had, you can do it, Jeff. What if I had this? Add 5. Isolate. There seems to be a theme occurring. Isolate where my x is, because then I can do it easier, right? So we know I have to isolate the absolute value. And then what do I do? Yeah, so you get x equals 4 or x equals -10. Yeah. Okay. So what's that got to do with us, Jeff? All right. So now you can kind of, oh shit, well, you all know this quiz is happening.
It looks like it's a -4.
So what would I do? So first off, I'll get to this. I wanted this idea out there. But what do you think you do to solve this? The idea here is, how do I solve this? I do the opposite of division first. How do I solve this? I do the opposite of subtraction first. So how do I solve that? What do I have to undo? The opposite of the square root is? Square. So if I square both sides, what happens here? These cancel. So I get x equals. And that's ground shaking. Right? Square root of what is 2? 4. I didn't have to do algebra for that. Right? Just think about it. I like it. But that helps me for when the problems get worse. So here's what my other point was with this was, can I make, I don't know if I can talk. If I squared both sides right now, what people wish would happen is you would square this, and you would square that, and you would square that. No, that's shit. If I square both sides right now, I'd have to FOIL this. Oh my God. So the point here was, things are possible, or at least easier, if you isolate the thing that has your x in it first, right? So what's the first thing I should do? Add 4. My God, please, dear God. Please. So I like to make the joke that this is sort of like I'm teaching you how to be a tyrant of a country. If you have a radical element in that country, what do you do with them? You isolate them, and then you kill them, right? Oh, boy. Jeff, you're all cool with the zombies dying, but now I'm talking about countries killing radicals. Because now I've isolated my radical element. How do I kill it? Square. Good. X minus 7 equals 36, so x equals 43. Now, just like with rational equations, remember when there's like an x plus 2 on the bottom? So if I had an equation that had this in it, blah, 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 what could x not be at the end? If I get x equals -2, I have to say no solution, right? So same thing here. Don't radicals have problems with their domains? You must check your answer to make sure that nothing goes freaky. And sure enough, when I put 43 minus 7, I get
36.
That's fine. Square root of 36 is
6.
minus 4 is
2.
yay! All right. But you must check your answer. Because there will be some times where you get bogus answers, just like we got bogus answers over there. For sort of the same reason, there are domain issues. Some values can't be used. But it's even more than that. And we'll get into that here in a minute. In fact, you can see it very easily. The easiest equation to make that has no answer with radicals is something like this. All right. Right off the bat, I know there's no answer. You guys seeing what I'm saying? Why? The square root is defined to be the positive root. So square root of x can't be -3. But if you start to solve it, Do you see any problems when you solve that? 9. Circle. Next one. But if you plug it in, square root of 9 is not negative 3. So you see, another reason why bogus answers might show up is when I square things, I forget that they were negative. So math says, all right, here's an answer, and we're like, oh shit, it was negative, not positive. I'm sorry, man. No solution. But if you see this, dear God, don't do any work. Just say no solution. That can't happen. Square root cannot be negative, just like absolute value can't be negative. Okay. So here, try this one. Sure, I like it. So there's nothing tricky there, no weirdness. Your answer will be a fraction, but it doesn't mean anything bad. As long as your answer doesn't make this negative, as long as it makes the equation true, you're fine. So you guys get a fraction?
Yeah.
Let's see if you got the right one. What do I do first? Isolate your radical element. I like it. So subtract 5. Square it to kill your radical element. Kill the radical element.
2x plus 1 equals 16.
2x plus 1. One big mistake right here is people square the 2x plus 1. And then the problem becomes way worse than it's supposed to be. The square is dead. No square left for that. And then you subtract 1 divided by 2, so you should get 15 over 2. I like it. If you plug it in, 15 over 2 times 2 is 15. Plus 1 is 16. The square root of 16 is 4, plus 5 is... Shit! Okay. So, here's the last problem we'll do for today. Everybody sits up a little straighter. Last problem. Alright, you gotta be careful. I gotta make this one work. Let's see. I'll make it too freaky, Jeff. Okay. Yeah, that should work. Yes, okay. What's a little different here? There's an X over there. Shit. Still do the exact same steps. The process doesn't care what's in there. So let me do this with you guys. So what's the first thing you do?
Add 1.
Add 1. I like it. Isolate the radical element. Square both sides. Just square this side, square that side. Now please, dear God, this is where people give me this. Now if you gave me that right now, erase it and smile at me. What's wrong with that? How do you square x minus 3? So the people that wrote that, they missed the middle term. So it's x squared minus 3 minus 3x minus 6x plus 9. There you go. Don't forget how to FOIL all of a sudden. Right? Now, what tells me what to do next? Oh, shit. What tells me what to do next? What? Well, no, not right now, though. If I factor it right now, that sucks. Yeah, the x squared tells me what to do. I got to get it equal to 0. So, yeah, I don't want to factor it out. I got to get it equal to 0, so it actually means something when I factor it. 0 equals x squared x 6 The answer is not 7 and 1, right? This is where people tell me that. They got to multiply to be 6 and add to be negative 7. So it's, they're both negative, right? Let me stop there for a second. This is going to happen when there's an x over there. You're going to get x squared business. You're going to have to get it equal to 0. That's why we learned that whole thing, because who knows when that could happen. It happened here. So I get x equals 6 and 1. Before I circle those, I got to make sure they work. See, this is our last problem. This is a long one. Sorry. So, I got one too. Happy about it. So if I plug a 6 in there, I get 6 plus 3 is 9. Square root of 9 is 3. 3 minus 1 is 2. And when I put